So the next generator we're going to talk about is the FM generator. So FM is very similar to the BFM generator. The difference is that instead of the carrier modulator being two oscillators, they are each just a single oscillator. Because of this, you lose some complexity, but you gain some simplicity in controlling the parameters because all the parameters fit on a single screen. And also, the FM generator uses about 35% less processing power than the BFM generator. So if you're running out of cycles in order to get all the tracks that you need in your song, then using the FM generator might be a good idea. So in order to access the parameters, what you can do is you can press triangle along with the left trigger and right trigger. And what that does is it brings up the menu for the currently selected track, which in this case is the FM0 track, because you can see that the Y value in the lower left-hand side of the screen is 2, and FM0 is the third track. So then we're going to select Gen, and now we have this list of parameters, and these are all the parameters that control the functionality of FM0. Now, if you remember, for BFM0, it took 2 pages in order to hold all the parameters. 1 page for the carrier, and then the other page for the modulator, and the modulator's envelope. So, let's see. So the top 7 parameters control how the carrier works. Carrier freq is the frequency of the carrier, and carrier WT is the waveform for the carrier. So it's the wavetable for the carrier waveform. Carrier warp and carrier warp wavetable provide the frequency of warping characteristics that I explained in an earlier tutorial, and expmult and end offset allow for pitch bends on this generator. So then carrier SH is the sample and hold characteristic, which causes the output to be held for a certain number of samples. So there's no osmix or ring mod parameters because there's no second waveform to mix with. There's just a single waveform in FM. So then after that we have mod index, which controls the index of modulation. And so the larger this value is, the stronger the FM nature of the sound. So briefly, I'll bring that up. So I'm holding triangle and have the using the analog pad pushing up. Mod index goes up. So you get that typical sort of FM-y kind of sound. Bring it back down again. And again, I'm holding triangle to make this modification because we have all the control steps for this track, and we want the same value to be loaded into every step. So triangle causes the value of the current step to be loaded into every step. So then the next 6 values are the modulator's envelope. So these are exactly the same as they were for BFM. So first of all, we have delay, which delays the start of the modulator envelope. So the envelope is at 0 for the amount of time indicated by delay. And then the next parameter is attack, and this is the amount of time it takes for the envelope to go from 0 to fully open. This is time in seconds. Decay controls the amount of time it takes for the envelope to go from full scale to the decay min value, where decay min is ranges from 0 to 1, so or just greater than 0 to just less than 1. So in this case, it takes 1 second for the envelope to go from 0 to 100%, and then 1 second to go from 100% to 50%. And if I set decay min to, say, 0.14, then it takes 1 second for it to go from 100% to 14%. The next parameter is sustain, and this is the amount of time that the envelope is held at the decay min value, so it's not being held for any period of time at all at 14%. But if I was to bring this up to say like 2, then the modulator envelope is held at 14% for 2 seconds. And then release is the amount of time it takes for the modulator envelope to go from 14% to 0%. So in this case, it takes 2 seconds for that to happen. The next set of parameters are for the modulator, and so there's only a couple of parameters to control the modulator. The first one is a sample and hold value, which again controls the amount of samples that the amount of samples that the modulator is held at its current value. And then there's mod offset, which works in the same way as the modulator offset in the BFM generator, in that it's not a frequency, it's a ratio of compared to the frequency of the carrier. So in this case, the carrier frequency is E4, which is about 160 hertz. So that means that the modulator frequency is going to be twice that, about 320 hertz. And then after that, we have the waveform for the modulator. In this case, it's the sine wave. And then the last 3 parameters are the same as they are in BFM, in that this FM generator supports feedback. So there are 4 types of feedback in the FM generator, and you can select those by setting the FB type, whether or not you want the output of the modulator to go into the modulator carrier and the output of the carrier to go into the modulator carrier. And then carrier feedback and modulator feedback set the amount of feedback that is sent from the output of the carrier and the output of the modulator into the appropriate oscillator based upon the FB type parameter.